Hello everyone. Our group is the Database Busters, and our presentation focuses on database security. A database is an organized collection of data. In many cases, this data is comprised of confidential financial and personal information. Keeping this information secure is critical for most businesses and even personal home computer users. 96% of records breached are from databases. Various industries use databases to store such information. A few worth noting are banks, universities, credit card companies, sales and finance, and human resource departments. With all this information stored on a database, there is plenty of motivation for attackers to try and access or alter this information. If an attacker can gain access to this information, they can use what they obtain for their own personal financial gain or apply it with criminal intention. With that said, it is easy to see why it is important for database users to administer some type of security procedures. But shockingly, in today's society, only 5% of security implementation is spent on database security. So why is it important for technological industries to take database security measures more seriously? Here are just a few examples of the consequences of what can happen with a security breach. After an attacker has gained a user's personal information, this can easily lead to identity theft. The attacker will use your identity to max out your credit cards and drain your bank account before you even realize your identity has been stolen. Attackers also sell personal information on the black market, such as social security numbers, credit card numbers, and so on to other criminals. This is actually a more common occurrence than one may think. From a business standpoint, an attacker may be looking to sabotage a competing business by accessing their database and destroying or altering their records. This can cause extensive financial problems to a company, along with customer dissatisfaction, causing their customers to now take their business elsewhere.
So now you guys are probably wondering, has this ever happened before? Unfortunately, the answer is yes. On January 25th, 2003, a computer worm surfaces sometime in the morning in Asia. The worm starts to install itself on computers running a faulty version of a Microsoft database packet called SQL Server 2000. The worm bombards random computers with small packets of information. It was able to spread more and more packets over time as more computers were infected. This gave it the nickname Slammer, and since it installed itself on the SQL server, it gave itself the nickname the SQL Slammer worm. Unfortunately, since the virus occurred sometime during the weekend, people were not at work and the problem was not able to get patched. Because of this, the virus was allowed to spread unchecked throughout the entire weekend. By Sunday morning, over 120,000 systems had been infected, anything from computers to routers to ATMs and anything else that had some sort of computer in it. The virus had also spread to multiple countries, including the US and South Korea. That morning, South Korea suspected a coordinated attack was launched on their national communications infrastructure. The country's information and communication minister, Lee Sung-chul, said that the worm had caused total internet breakdown. In the U.S., they were also starting to feel the effects of the worm. Over 13,000 Bank of America ATMs started to become unstable by either not working or stopping completely. The Computer Emergency Response Team, also known as CERT, issues an alert saying that the worm was able to gain control of the device it was infecting, even though that they had no proof of this at the time. By the time the worm stopped infecting machines, over 120,000 of them had already been infected. This was caused by creating a buffer overflow that it exploited in the software security update that Microsoft had released. A buffer overflow is when a program starts to write too much data to a buffer, in which case it becomes overloaded and starts overwriting adjacent memory. Microsoft had actually found this issue and released a patch for it 6 months earlier in 2002, but many companies did not feel the need to install the patch and ended up leaving themselves with this huge security vulnerability. So you're probably wondering, how did this worm work? First, it started spreading by infecting and crashing all routers in the area. This caused massive amounts of internet traffic. It infected hosts over a sessionless UDP protocol, meaning that it could actually get onto a network or computer without needing permission from the host it was infecting. The entire worm was also able to fit inside a single data packet that it ended up only being about 376 bytes of memory. Infected computers would then fire these small packets extremely rapidly, usually hundreds of packets per second, to other computers.
Databases are often managed by complex querying languages such as SQL. As previously stated, SQL injection on an unsecured database can cause data breaches, data modification, and unauthorized privileges. Although no platform is ever truly secured, there are a variety of defenses a database administrator can use to help minimize the risk of SQL injection, including limiting user input, prepared statements, and web application firewalls. One of the simplest methods of preventing SQL injection is to prevent a user from inputting information. This isn't possible in most real-world applications. However, if a developer reduces the amount of places that a user has the option to input information, there are also fewer places that an attacker can try to inject malicious code. It also allows the developer to focus on making the inputs that do exist more secure. In the event of an attack, figuring out what went wrong and fixing the vulnerability that allowed the attack to happen would be much simpler. If user input is not filtered properly, an attacker could send unwanted data, including commands, through any place that user input is accepted. A prepared statement allows a user to input data as they normally would, but separates input data from queries. A prepared statement essentially tells the database to handle input as a parameter that is being passed through, and to use it only as a parameter. This means that even if a command is sent through where the data is supposed to be, it will not recognize it as a command and will simply treat it as a parameter. A database will also benefit from having a web application firewall. They work by scanning the information sent to the database before it can reach it, and stopping any data that appears to be malicious. They can be especially useful in high traffic, high risk, and complex databases, since attacks are constantly evolving. The database of known malicious inputs is constantly updated and allows a database manager time to implement a fix without having to worry about a new type of attack occurring. Firewall should not be a first line of defense, but an addition to a database with optimized security measures implemented.
So now that you know about the motivation behind database security and SQL injection, let's take a quick break to ask the question. What is the primary reason that database threats remain a problem today? A. Adequate security measures don't exist for companies. B. Hackers already took ELE 438 CSE 418. C. Most companies don't take the problem seriously and don't invest enough funds into database security. Or D. Database threats are not a problem. Moving on. On October 21, 2002, 9 of the 13 DNS servers were attacked by hackers. The attack was carried out by creating a link from old domain names to fake IP addresses. The result was that 7 of the DNS servers were down and all 9 were receiving an increase of 40% traffic. The servers were likely to have been crashed if the attack lasted any longer than an hour, and this is considered one of the most sophisticated attacks in history, known as Code Red Warm Assault on the Web. Now that was an example of a denial of service attack. Now this is caused by several reasons. Buffer overflow, which is when too much data is passed to a buffer. Data corruption, which is as a result of buffer overflow, and is when the excess data overwrites adjacent memory. Network flooding, which is when networks experience an increase in traffic and become congested. And resource consumption, which is unique to database attacks and is caused by time-consuming queries. So how do we defend against that? Well, the first and most obvious reason is we need query optimization, which means that the code itself needs to be written efficiently in order to optimize speed and memory usage. It is necessary to reduce execution time by checking the conditions of a query statement in optimal ways, since the entries in a database are numerous. Query whistling, which is execute only resource limiting queries. So we create a whitelist, which is the opposite of a blacklist. By keeping a record of these realistic queries that we expect a typical user to ask, we can ensure that only resource limiting queries are executed. By the use of error handling and input checking, buffers will never be overfilled. So as you can see in this first picture, it says your query could not be completed. Okay, so if a user asks for too much information to be returned, then he will get a message and the database will not crash. Okay, input validation, we could require a login so that a user can only ask queries if they are logged in, and this helps prevent spam. Database monitoring, which consists of IPS and DAM. IPS, intrusion prevention system, means monitoring network traffic based on signatures and blacklisting IP addresses which do not resemble human behavior. This prevents network flooding. DAM, Database Activity Monitor, monitors all activity even by the database administrator by gathering, evaluating, and storing the records in a separate location from the database. So even if the database records were hacked, these records would not be. And as you can see over here on the second picture, we can implement a spam filter. And we do this by keeping track of the IP addresses that visit the website. And any IP address that exhibits an unusual amount of traffic, we can ask them a similar message such as this one. In conclusion, while there are measures that a company can benefit from, malicious attacks on databases remain a problem because most people do not recognize the importance of this topic. Thank you.